Guys, we are about halfway through our 5th chapter, and we are going to talk about some of the special types of parallelograms. And a lot of these I'm sure you have seen before, but we're actually going to talk about some of the specific properties that they have and that make them unique and different from each other, but also some of the properties that they share. So first one up is a rectangle, which I know you have all been seeing rectangles since you were like 3 years old, but now you get to know the specifics. So a rectangle is a parallelogram, but it has 4 right angles. That's its special rule. It has all 4 right angles. The other properties that it still has are the opposite sides are both parallel and congruent, which is a property of parallelograms. The opposite angles are all congruent and are all 90 degrees. Oops. Okay, because they're all right angles. The consecutive angles are supplementary. Remember, they add up to 180, which makes sense if they're all 90 degrees. The diagonals bisect each other. And the last one is that the diagonals, this is special for rectangles, the diagonals are congruent. So 1 through 4 are basically properties of parallelograms, but number 5 is special, that the diagonals are actually congruent. So in this first example, we have our quadrilateral ABCD, and it's a rectangle, so that means all of those properties we just talked about are true. And it says if ACD, so this bottom right angle, is 5x plus 1, and the measure of angle DBC is 6x plus 1, find x. And what we can do is set this equal to 180 by saying the measure of angle ACD plus the measure of angle DBC plus 90 equals 180. Because this little angle ACD is congruent to this little angle up here. And let me mark this a little better. And the angle DBC that we already have marked is congruent to this big angle down here. And all of that together has to add up to 180. So that's the equation we can use. So we've got 5x plus 1 plus 6x plus 1 plus 90 equals 180. And this looks like an equation you can solve. But if you want to keep going with me, I got 11x plus 92. So 11x equals 88 for a final answer of x equals 8. Our proof practice, okay, we have EFGH is a rectangle, and we're going to prove that the two triangles EHG, so this bottom left triangle, and FGH, kind of the bottom right triangle, are congruent. So I'm going to fill in a few of the steps, but leave it open for you to finish. Of course, start with your given information. Okay, so that's our given. The goal is to get to triangle EHG is congruent to FGH. Sorry, triangle FGH. And remember, proving triangle congruence, we can use side, 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 angle, side, angle, side, angle, 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 side, and we can use hypotenuse leg if we know we have right angles. So I'm going to say that my second step, I'm going to clarify that EFGH is a parallelogram, and that's just by definition of a rectangle. And the last few steps, I'm going to leave open for you to prove using side, side, side that these triangles are congruent. So these three boxes should have 3 pairs of sides with 3 justifications in them. So that one I'll leave open for you. The next 2 types of special parallelograms we have are rhombi and squares. So a rhombus is, again, a parallelogram, and this is our symbol for a parallelogram. I'll make it a little bigger. So just like how for triangles we draw a little triangle, for a parallelogram we can draw a tiny parallelogram. So it's a parallelogram with 4 congruent sides. So all 4 sides are equal. And the other 2 properties are the diagonals are perpendicular. Okay, so in the middle of your rhombus, you've got 4 right angles, and each diagonal bisects a pair of opposite angles. So what that looks like on our picture is these corners are bisected by the diagonals. Okay, so we have a rhombus here with a couple of practice examples that says the measure of ABD, so this angle in the top right corner is 42, find the measure of DAB, which is this entire angle over here. So the way we can set this up is actually by saying, that 2 times the measure of angle ABD plus the measure of DAB is equal to 180. And here's why we say 2 times. Because we know that diagonal bisects it, I know that I have 2 equal measures in the top right corner of my diagram here, and I know my consecutive angles, because it's a parallelogram, have to equal 180. So now I'm going to fill in everything I know. So 2 times 42 plus, I'm going to call this I'm going to call it A, equals 180. And then I got 84 and A. So my angle is equal to 96 degrees. And now I'll fill it in, angle DAB. Okay. Our next one has to do with same diagram, but now using segments. Okay, so AE is 9, AB is 15. Find DB. So this will require a little bit of Pythagorean theorem, and I'll kind of get you set up, but I'll leave it open for you to solve. So AE, the whole segment squared, plus EB squared equals AB squared. Okay. So using this, we can solve for EB. And sorry, I labeled one of my sides wrong. There we go. That's the 15. Okay, so we can solve for EB. And then once you solve for EB, you can solve the second equation that says 81. And I'll let you figure out where the 81 came from. Plus EB squared equals 225. And once you know EB, you can use that answer to find DB, because remember, your diagonals of a rhombus are going to be split in half, okay? Or the diagonals bisect each other because it's a parallelogram, okay? And then the last one, a square, is just a special type of rhombus. So it is a rhombus, but it has 4 right angles. So this little Venn diagram down here, we have rectangles which have 4 right angles, right? We have our rhombi over here, which have 4 congruent sides. And in the middle is where the squares exist because they have both the properties of rectangles and rhombi. So a couple of things for you to finish. You have the proof to finish and problem number 2 about the rhombi, and then there's going to be some textbook problems to follow up with. Let me know if you have questions, reach out, and I'll see you guys again soon.